Hi, I'm Robin Sanders, and I'm the instructor for Math 103 CRN 1846 this spring at Buffalo State College. I want to tell you a little bit about myself, and then I also want to tell you a little bit about the course that you're taking. I am a PhD mathematician. I earned my degree from the University of Illinois at Urbana-Champaign a long time ago, and we moved to Buffalo State for my tenure track position at the time in 1997. Since coming to Buffalo State, I've done a little bit of everything. I'm actually a former chair of the department, and I've taught everything from Math 103 all the way up through our graduate courses. I enjoy teaching 103 because it's an interesting course. Math 103 is designed for students who are in majors that are never going to require them to take another math course. And they also are never going to be required to take another statistics course. So Math 103 doesn't have to prepare you for another math course. Of course, part of this is also that Math 103 attracts a lot of students who don't particularly like mathematics. And so if you really don't like mathematics, that's okay at this point. The purpose of Math 103, or at least one of the purposes of Math 103, is to get people to understand how somebody like me can fall in love with mathematics, that there's a certain beauty to mathematics and a certain creativity to mathematics that appeals to certain people, among them, obviously, mathematicians. And so this is a course about mathematics. It's about some big ideas in mathematics that you probably haven't been introduced to in your high school mathematics courses. And you certainly haven't been introduced to them in the way our author covers them. And so it's important to kind of keep an open mind, and that's really one of the purposes of this course, is it's to try and get you to be willing to open your mind to the idea that even if mathematics is not your cup of tea, that it is an interesting, dynamic, and aesthetically pleasing human endeavor, that it's created by human beings, and there's a certain beauty in how it all fits together. Now, we're going to start the semester off with the idea of order and disorder and how it leads to something called fractals. And fractals are part of very modern mathematics. They were invented or discovered less than 40 years ago. I think it was about 30 years ago, actually. And there are all kinds of applications all over the place about fractals, but what we're going to be interested in is the fact that they are very pretty looking and that there's a lot of ability to play with them. After we do fractals, we'll move on to something that our author refers to as dimensional analysis. And dimensional analysis is an interesting chapter in that it gives you an idea about the difference between how users of mathematics and how mathematicians tend to think about things. Mathematicians are happy to just think about a number in isolation as itself. If we look at the number 4, mathematicians don't typically ask for what's, but a scientist or an economist or a social scientist is going to ask 4 what's. Are you talking about 4 eggs? Or are you talking about 4 miles? Or are you talking about 4 million miles? Or are you talking about $4 billion? And all of those things are examples of putting what are called units on the number. And it turns out that numbers with units play an extremely important role in all areas of applied mathematics and in all of the basic applications that people think of when somebody says, how is mathematics useful? So after looking at some dimensional analysis, we'll then move on to looking at a little bit of probability and random numbers. And we'll be looking at using computers, a computer program generated by the authors of the textbook, to do simulations so that you can really see how probability works in action as opposed to looking at lots of dry formulas. So we'll look at several different kinds of models that are based on probability. After we deal with the probability and modeling, We're then going to hit the highlights of the calculus sequence. Now, calculus is this big, scary word for a lot of people, particularly if they know anybody in Math 126 or Math 161. But what we're going to do is not get our hands dirty in the mechanics and all of the theory that a science major or a math major really has to learn in courses like 126 and 161. What we're going to do is we're going to focus in on the big human achievement that Newton and Leibniz did when they came up with calculus. We're going to look at the fundamental ideas of calculus and just get our toe dipped in the pool of calculus to find out why it's so important and why it is considered in the world of mathematics one of the crowning achievements of humankind, not just mathematics, but of genuinely humankind. It's a really big idea. And then we'll end the semester looking at what our author calls alternative geometries. It turns out that the geometry that you studied in high school is not really the geometry that human beings live with when we're dealing with the fact that we live on the face of the earth, which is in some sense a big round ball. So we'll be looking at what is called spherical geometry, both where it comes from and how it works. And then at the very end of the class, we'll get our minds blown by looking at something called hyperbolic geometry, which was discovered at the end of the 1800s, the beginning of the 1900s. So that's the whirlwind, what we're going to be doing. And I hope that your mind is open enough for the idea of taking a mathematical adventure, because that's really what Math 103 is all about, is to take you on an adventure, to look at some ideas that are big and interesting and represent major achievements in human endeavor.